Good day once again, class. Welcome to another session of our subject, differential equation. Right now, we are still on the first order, first degree differential equation, and our method to be discussed today is Bernoulli's differential equation. So, Bernoulli's differential equation, as it says here, is an extension of a linear differential equation, which is created by Jacob Bernoulli. This is still a first order, first degree differential equation. So, as I've told you last time, what happened if your q of x have another variable like y, then q of x, or your q of y have another variable which is x. So, linear differential equation cannot solve those problems. So, in order to solve that one, we will be using Bernoulli differential equation. So the same process in the linear differential equation, except that we will need to derive some terms or some parts. So it's as I've told you, this is first order, first degree differential equation. Then it will follow the general form, which is m of xy dx plus n of xy dy equals 0. And it will follow this standard form written below. So here, the same as your linear differential equation, it still has Bernoulli in y and Bernoulli in x. So in Bernoulli in y, so if you could see, it is the standard form is looking similar with your linear, except on this right side part, the q of x has another variable which is y. Okay, so in linear differential equation, the right side is only q of x. So in this case, this is the standard form of Bernoulli differential equation. So from here, in order to solve Bernoulli differential equation, we need to get this variable out and divide this both sides with this value. So it will look like this, and also this one. After that one, so obviously, when you divide this one, this becomes negative. And this one, the power of this, which is 1, minus the power n. After that, this y raised to the power 1 minus n will be equated to variable m. Okay? So from here, this m needs to be derived. So it needs to be derived. So for example, this is y raised to the power of 2. So you need to derive y squared. So that is 2y dy over dx. So still, when you derive, that is the power minus 1 times that power. Diba? That's how you derive. So from there, so 1 minus 1 becomes 0. So what remains is negative n. So from here, what you get here, because what we are trying to do is to replace this part, y raised to the power of negative n dy over dx, with our value of dm over dx. So from there, we just transfer 1 minus n to the other side so that we can have our y raised to the power of n dy over dx, which we will substitute here. Okay? So from there, we already substitute it, which is this one. So after that, you now can continue simplifying this one. So from here, so that you will go back to looks like linear differential equation. So this one, obviously, it is a constant. So you multiply it so that you could cancel. So your constant will be multiplied here and also here. From there, you can now get your p of x which is the number multiplied to your p of x original, and your qtx. So now we call this one ptx, not, so that we could identify that this process follows Bernoulli differential equation, and qtx for the one on the right side. Then the same situation that we will be doing in integrating factor. So integrating factor e raised to the power of your p tx dx. After that, in the general solution, so in linear and y, you put y here. But in this case, if you could still remember, what we have here is your y raised to the power of 1 minus n, which is our m. So therefore, in the general solution, your m will be multiplied to integrating factor, which is equated to the integral of qtx multiplied by integrating factor dx plus c. So let's try some example. So to further test, okay, so let's try to write dy over dx, okay. So dy over dx plus y 2 over x times 2 over x equals 3y cubed x cubed x squared. Let's check. Sorry, this is wrong. This is dy over dx so that is dy over dx y 2 over x equals 3y squared x y cubed x squared. Okay, let's start solving. And we look into that this is Bernoulli in y. Okay, so from here we could see that we have our p of x, but our cube x have still the value of y. So from here, just simply, what do we do? Divide both sides. So divide both sides by your variable y cubed. Right? So what we have here is dy over dx over y cubed. So from there, plus, so you have y over y cubed times 2 over x equals, so divide this one, so you have 3x, so let's just write it so that we will just cancel it, 3x squared y squared over y cubed, because we divide all sides. So from there, so we could now simplify this one. We could simplify this one, and we could cancel this one. So from there, okay, so from there we have dy over dx over y, or we will make it like this. So we raise this one up, so we have negative 3 dy over dx plus this one. So you have y raised to the power of negative 2 because we have 1 over y squared. So that when you make that one, that is just equal to y raised to the power of negative 2 times 2 over x equals 3x squared. So now we already have this one. Now we will get this part. Okay, we will get, so we want to get this part. So that part will be derived. So that is our m, which is y minus 2. So we will derive that one, which is dm over dx, which is equivalent to derivative of that m over dx, where when we derive that one, that is derivative of y squared, that is negative 2y dy over dx. So from there, so we have, okay, sorry, we still have here, okay, where is it? So we have negative 3 here, negative 3, because we have, when we derive this one, we multiply it in front, then we minus 1. So negative 2 minus 1, that is negative 3. So from there, we try to get, this is very important part. So actually this part, let me box this one. This is actually important part. This is really important. This is, let's say this is our one. Okay, that is very important because later we will be substituting this one with the value that we get when we derive. So from there, we have to transfer, because if you could see, we have y cubed, y raised to the power of negative 3, which is this one, dy over dx. So in order to substitute this one with the value, so we need to eliminate the negative 2. So eliminating, or just transfer it to the other side. This is multiply, so when you transfer, that is divide. So therefore you have dm over dx all over negative 2, which is equivalent to y negative 3 dy over dx. So therefore our y negative 3 dy over dx is equal to this. So I just write this one, dm over dx over negative 2. So after that, so we can now substitute this one. Let's say, let me just write this one as 2. Let's now substitute 2 to 1. So substituting that one, so you have your y cubed will be dm over, dm over dx all over negative 2 plus y negative 2 over x, okay, equals 3x squared. So from there, so that we could make this one as dm over dx, like dy over dx, diba? So in linear differential equation, we need to multiply by negative 2 so that this one will be eliminated. So multiply both sides by negative 2. Multiply both sides by negative 2. So therefore you will have dm over dx minus, let's make it plus That is